Organizing and summarizing data. Lesson objectives: organize qualitative data, construct bar graphs, construct pie charts. When data is collected from a survey or design experiment, they must be organized into a manageable form. Data that is not organized is referred to as raw data. We're going to look at 3 ways to organize data: tables, graphs, and numerical summaries in Chapter 3. We're going to begin with tables. Organizing qualitative data and tables. A frequency distribution lists each category of the data and the number of occurrences, or sometimes it's referred to as frequency, for each category of the data. Let's look at an example. The following data represents the colors of M&Ms from a plain bag of M&Ms. Construct a frequency distribution of the color for the M&Ms. So this is our raw data. It's very hard to glance at this raw data and get anything from it. It would be hard to see which one occurred most often, least often. It would just be hard to read. But if we construct a frequency table for this distribution of colors, we would get some insight. If we go by color for categories, we have brown, yellow, red, orange, blue, and green. We tally each of the colors, and then we write down the corresponding frequencies. We have a frequency table, a frequency distribution. Very easy to see that brown is the most often, the least often would be blue, so on and so forth. Okay, the next table we're going to look at is what we call a relative frequency table, or a relative frequency distribution. Okay, the relative frequency is the proportion, or sometimes is expressed as a percent, of observations within a category and is found by the following formula. The formula is you take the frequency and divide it by the sum of all the frequencies. A relative frequency distribution lists the relative frequency of each category of the data. Let's look at an example. If we take our frequency table for colors of M&Ms, we can extend the table to include a relative frequency by first summing all the frequencies of all the colors, which turns out to be 45, and then dividing each frequency by that sum of frequencies, 45. So 12 divided by 45 is about 0.2667. 10 divided by 45 is 0.222. 9 divided by 45 is 0.2, so on and so forth. These also can be expressed as percents. So for example, orange is about 13%. Blue would be almost 7%. So we are summarizing this data by using tables, both a frequency table and a relative frequency table. Lesson objective number 2, construct bar graphs. Bar graph is constructed by labeling each category of the data on either the horizontal or the vertical axis, and the frequency, or it could even be relative frequency, of each category on the other axis. Let's use our M&M example. First we will do a frequency bar graph, and then we'll do a relative frequency bar graph. As we can see, we have 12 for brown, we have 5 for blue, so on and so forth. Now this was done in Minitab. This could also work in StatCrunch. It's constructed very easy by using these programs. Okay, relative frequency, the y-axis is now going to be a percent or a decimal. Okay, so if we look at the brown, we can see the brown is about 27%. Blue is about 6%, 6 or 7%. Now, a Pareto chart is a bar chart where the bars are drawn in decreasing order of frequency or relative frequency. Okay, so this is what a Pareto chart would look like using our M&Ms. Why do we need to look at a Pareto chart? Well, Pareto chart is used to graphically summarize and display relative importance of differences between groups of data. Pareto chart distinguish vital few from useful many. This is also known as the 80-20 rule. 20% here makes up 80% here. That's the 80-20 rule. Let's look at some examples of where this is applied in the real world. 20% of workers contribute 80% of the results. that happens, you want to focus on rewarding these employees. 20% of the bugs contribute 80% of the crashes. You want to fix these bugs first. If 20% of customers contribute 80% of the revenue, you want to focus on satisfying these customers. So the 80-20 rule, or sometimes it's called the Pareto principle, helps you realize that the majority of the results come from a minority of the inputs. So let's look at an example of a Pareto chart using data from a pizza shop. So here's some old customer complaints before they mastered the 30-minute pizza delivery. So they had 600 complaints, pizza was not hot, inadequate topping, quantity is 105, and we have all these different complaints. So the first thing that we want to do is we would want to construct a Pareto chart for this data and solve those problems first. The data has been summarized where you can see that the 20% is causing 80% of the complaints. So delayed delivery and pizza not hot are really what we need to focus on. Lesson objective number 3, construct pie charts. Okay, a pie chart is a circle divided into sectors, and each sector represents a category of the data. The area of each sector is proportional to the frequency of the category. A pie chart lets us see one category in relation to the whole. Okay, so this is a pie chart that's constructed in Minitab for the colors of M&Ms. And we can see here that brown is the largest. The next largest is yellow. Now it is colored in green, but that's just the color Minitab picked. Okay, red would be the next, and we can see the corresponding percentages. Thanks for watching.